in the morning sun. I'll be sitting in the evening come, watching the ships roll in. Then I'll watch them roll away again. Yeah, I'm sitting on the dock of the bay, watching the tide roll away. Just sitting on the dock of the bay, wasting time. I left my home in Georgia, headed for the Frisco Bay. I've had nothing to live for, and look like nothing's gonna come my way. So I'm just gonna sit on the dock of the bay, watching the tide roll away. I'm sitting on the dock of the bay, wasting time. Look like nothing's gonna change. Everything still remains the same. I can't do what 10 people tell me to do, so I guess I'll remain the same. Just sitting here resting my bones, and this loneliness won't leave me alone. It's 2,000 miles I roam, just to make this dock my home. Now I'm just gonna sit at the dock of the bay, watching the tide roll away. Sitting on the dock of the bay, wasting time.
Okay. So, ladies and gentlemen, good morning to you. Welcome back. We are beginning our chapter 2. And this is all on circles, so I figured I'd start off with a little video showing you some real-life examples of where you can see circles in the real world. Okay, so this is actually a neat unit because, again, you've seen circles pretty much your entire life. There's lots of different applications with them. If anyone here enjoys sports, almost every single sport involves a circle or a sphere in some way. Alright, so we're going to talk about the basics of them today, talk about a few theorems, and then see if we can put that to use. So, here we go. Intro to circles. Key vocab. A circle is a set of all points on the plane that are equidistant from a given point, called the center of the circle. Okay? We call a circle by one letter, whatever that center point is. So I'm going to call this circle P, and that's what we call it. Okay? Sometimes you'll see me use this little symbol next to it, just a circle with a dot in it. Okay? The distance from the center to a point of the circle is called the radius. Here is your radius. Okay, we use lowercase letter r for that. Two circles are congruent if they have the same radius. That's all we need. If you have two circles that have the same radius, boom, right away you got them congruent. Okay? And a radius is a segment whose endpoints are the center of the circle and a point of the circle. Good enough. Alright, now, some more vocab. A chord is a segment whose endpoints are points on the circle. So if I just draw two random points on the circle and connect them, this is a chord. Okay? And it can be anywhere, all the way across it, wherever. Just 2 points have to lie in a circle. A diameter is a chord that passes through the center of the circle. Now this is a unique one. It's called a circle Q. If I draw a line straight through that point Q from one end to the other, this is your diameter. However, this is also technically a chord. But please note that not every chord, let's see if I can write this up here, not every chord is a diameter. Okay? But every diameter will be a chord. Okay? A secant is a line that intersects the circle at 2 points. So if I just draw a line going through this, here and here, okay, there is my secant, And lastly, a tangent is a line in the plane of a circle that intersects a circle on exactly one point. If I draw a line that touches the circle at just one point right here, that's my tangent. Okay? So we will get plenty of practice with words. Hopefully that drawing is not confusing you. If it is, say the word, I'll come over and help you guys out. Okay, tell whether the line or segment is best described as a chord, secant, tangent, or diameter or radius. CG. CG starts and stops right here. It's half my circle. That's going to be my radius. Okay. EG. Now this one's going all the way over here. Okay, so from one end to the other end. Yes, you could say chord, but the more precise word would be diameter. Okay. AD. Notice this is on the outside, and it only hits at one point. This point of tangency right here. That's going to be your tangent. HD. Notice I'm cutting all the way through the circle, all the way through. It's not starting and stopping on it. This is an example of your secant. And lastly, ray AB starts here, goes through here. Notice again, it's only hitting your circle at one point. That one point means it's going to be a tangent. Okay. A few key things to point out. This point C here in the middle is your center. And this point B right here is your point of tangency. I'm only saying this because I know it's going to come up on your homework a little later, and they're not hard, it's just, you know, that you haven't seen them right here. Theorem 10.1. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. Or in other words, if line L is tangent to circle Q at P, then line L is perpendicular to QP. If you have a tangent line drawn and your radius meets at that tangent point right here, this will always be 90 degrees, which is nice because it allows us to do some certain things. Okay. In a plane, if a line is perpendicular to a radius of a circle at its endpoint of a circle, then the line is tangent to the circle. This is just a converse. If L is perpendicular to QP at P, then L is tangent to to circle Q at P. There we go. Okay? So again, that right angle is being formed. Anytime we have right angles, we have the ability to use Pythagorean theorem. Okay, a squared plus b squared equals c squared. It's an awesome theorem that we're going to get very, very, very comfortable with, which is very helpful as well. Okay, flipping to the back. Theorem 10.3, it's our last theorem. If two segments from the same exterior point are tangent to a circle, then they are congruent. So out here, here's my tangent RS, tangent SR, but they meet at a point. Because they meet at that point on the outside of it, that means these are the same. So if line SR and line ST are tangent to circle P, then segment RS is congruent to segment TS, which means they have the same measure, which means you can set them equal. Okay. Here we go. Number 2. You are standing at R, 4 feet from a fountain. The distance from you to a point of tangency on the fountain is 8 feet. What is the radius of the fountain? Alright. Now, for this one, okay, what we're going to do is recognize that this is going to be a right angle right here. Okay, because it says point of tangency on the fountain date right there. So what we can do is we can do Pythagorean theorem. A squared plus b squared equals c squared. Because it's my right angle, here's my A, here's my B, and here's my C. The difficulty is realizing that, what is my C? Well, it's these two things added together. So it looks something like this. 4 plus R or R plus 4. Okay, because I'm just adding them together. So I'm going to plug everything into my equation. Let's see here. A is R squared, B is 8 squared, and down here I've got R plus 4 squared. Clean that up a little bit. Now this, I'm going to do a little thought bubble over here. R plus 4 squared is basically doing this. R plus 4 times R plus 4. Now this is your FOIL method. Okay. R times R is R squared. r times 4 is 4r. 4 times r is 4r. 4 times 4 is 16. And then I can combine together thoughts in the middle, or that the r's in the middle. There we go. Okay. So this, after doing a little bit of side work, ends up being this. R squared plus 8r plus 16. Alright. Now, good news, everyone. Alright. R squared on the left, R squared on the right. If I subtract R squared from both sides, they go bye-bye. So I'm left with 64 equals 8r plus 16. Subtract 16 from both sides. 48 equals 8r. Divide both sides by 8. R equals 6. Okay? So that one's a little lengthier. Don't panic too much when you see it. Again, just work your way through it. Pythagorean theorem, which we will provide you with. Alright? And it should be in good shape. Okay. AB is tangent, number 3, to circle C at B. AD is tangent to circle C at D. Find the value of x. If they're both tangent, guys, think about it. Look at the picture. These look the same. So we could set them equal to each other. X squared plus 24 equals 49. Okay? And I'm going to solve for this. Subtract 24 from both sides. X squared equals 25. Now, I'm going to square root both sides. X equals. When you square root both sides of an equation like this, I don't know if you guys have ever seen it before. It's not the end of the world if you haven't. But we have to put as plus or minus 5. Okay, because the reason being, 5 squared gives me 25, but negative 5 times negative 5 also gives me 25. However, because we are in geometry class and we're talking about measurements, do you think you can have a negative distance? Hopefully we're thinking no. So the only answer that matters is the 5. So really, this is something that's big in Algebra 2. Okay? I do want to show it to you as we continue through this class, so I give you a heads up on everything, but you get the idea. Alright, last few here, trying to get them all finished up. What are the center and radius circle A? The center is 0.32. And I'm just counting over 3 going up 2. The radius, just count from the center to the outside. 1, 2. Your radius is always positive. Okay? No matter which way I count, it will be 2. For my circle B, I'm going a little bit further to the right. This is 3, 4, 5, 6, 7, and then up 2. And my radius is still just 1, 2. Okay? Lastly, I threw this on here. The circle is radius r, your circumference is 2 pi r, and your area is pi r squared. Okay? This is something that I think you guys have seen before. We will give you the formulas if you need them. Okay? So number 6 over here, find the circumference and area of a circle. I need the radius. This is the diameter. How in the world could I ever find the radius? Divide it by 2. 6. So my circumference is 2 times pi times my radius of 6, which would be 12 pi. Okay? And what I would like you guys to do is use a calculator to help you calculate this. Now, I can do 12 times pi. If I hit second and this exponent key, it gives me pi. Alright? 37.699 or 37.70. And then because circumference, that's just units. Okay, it's not squared, it's just the perimeter on the outside. My area is pi r squared. So pi 6 squared. So I'm just going to do pi parentheses 6 squared, 113.097 or 0.10. And that would be units squared because we're talking about area. Okay? Whew. Okay, we finished them all up. Now, again, this is the beginning. We're going to take our time with it, but slowly running out of time here. So try this out, try your homework out, and as always, good luck. We're all counting on you.